what happens is we're going to continually use that idea that you guys did yesterday with the what's that called? Synthetic substitution. But we're going to start calling it a little something different. We're going to start calling it synthetic division. Because, as you guys are aware, when you divide stuff out, for example, 18 divided by 3. What's 18 divided by 3? 6. It's a nice clean number. But 18 divided by 5 isn't. That meant that 3 was a factor of 18, but 5 isn't. All right? There was no remainder. Now, when we did this stuff yesterday, we started talking about polynomials. We talked about polynomials being set up as like an nth degree. What's the degree of that polynomial? It's a fourth degree polynomial, which means how many terms should it have in its writing? 5. It has all 5. Descending order, fourth, third, squared, single, constant. Straight down the line. We also talked really quick yesterday about the number of possible zeros that it could have. If it's a fourth degree polynomial, how many possible zeros could it have? 4. That means that it could cross the x-axis up to and including 4 times. When you get a 0, that is where you cross the x-axis. You guys remember that from quadratics. Right. Now, what we wind up doing here is we start to think about, and this isn't going to be so much today. What we're going to look at today is what's happening on the tails of this equation, of this polynomial. What do the graphs look like? Once we start looking at the tails of graphs, we can figure out directions that the tails are moving. Once we know which way the tails are moving, then we can figure out what's moving in the middle. So with polynomials, a lot of times what we do, we start on the outside, and we work our way in. All right? But before I get into this specific big problem, what I want to do is take out the calculators and go through some pictures of tails. And what I want to do is I'd like you guys to put in your calculator y equals x, y equals negative x, y equals x squared, y equals negative x squared, y equals x cubed, y equals negative x cubed, y equals x to the 4th, caret 3, and then you'll have enough space in there to go x to the 5th and negative x to the 5th. The calculator has enough spots for you to do all of those. So take a second, type those in, okay? And then as you start to do that, what I want to do, excuse me, is before you don't hit graph or anything yet. I'm going to show you guys this little trick about how you can turn on or off graphs on the calculator itself. It's going to help us look at where things are going. What are things doing? That's kind of the idea here. Yes, sir. Oh, I'm sorry. It should be negative x to the 5th. Sorry about that. There. All right. Once you get through all that, you should still be in your y equals table part. Now, if you see where your cursor is blinking, you move your cursor over to the right so that way it's on the equals. See how mine is blinking on the equal right now? What I want to do is start with the second graph and just hit enter. And what I'm doing is I'm turning off all of those graphs. And just work all the way down. That way I don't have to retype them in here in a minute. We'll just have to turn them on as we look at them individually. Okay. So right now, the only graph that should be on in your calculator is y equals x. Oh, did I miss them? The only graph I should have on now is just y equals x. Everybody okay with that? All right. So let me explain to you guys what I'm talking about when I say tails. It's really, really easy to show with just the y equals x graph to start with. So here's what I mean by tails. As x gets larger, as x is getting larger, we say x is approaching positive infinity. As x approaches positive infinity, what is f of x approaching? What is y approaching? Same thing, it's also approaching positive infinity. The larger number I put in for x, the larger number I get for y, so this also approaches positive infinity. As x gets smaller, what's f of x doing? It's also getting smaller. Good. Did I ever tell you guys? Well, infinity. You guys understand infinity is an idea. It's a number larger, larger, larger. Yes, ma'am. Second plus 712. Second plus 722. We'll restore all of them. That's only 6. Okay, so that's what that means is things are moving, is what I'm talking about the tails. So the tails of x, of y equals x, go down up. Okay, they're going down up. Think of it as going from left to right, it's going down up. Okay, now go to your calculator. Turn on the negative x. Take graph. What is that one doing? The opposite. So the first one, our tails were down, up. The next one, the tails were, I'm sorry, they were, yeah, down, up. The other ones are up, down. Turn on the next one, x squared. What does the x squared do? Yes, Andrew. Reset. You did. Oh, you know why? You probably used the minus sign. Reset. Something's screwy in a table somewhere. Anyway, so the parabola, positive x squared, your tails were up, up. You don't even have to put this in the calculator to know what the tails from the negative are doing. Start, stop, select. A, B, B, A, whatever all the codes were. All right, now look at the next one. I'm actually, you know what? Before I go to the next one, I'm gonna turn off x and x squareds, all of those four, real quick. That way, you guys can start to see what an x cubed looks like. I don't think you've ever graphed one of those by hand. So if I go to the x cubed and turn on that one, what are my tails doing? They're down, up again. Down, up, okay? Now, take a guess what the negative version of that will do. The opposite, very good. So instead of down, up, it would be up, down. So now we are up, down. Okay? Go to the x to the fourth. I wonder. Up, up again. I'm betting you could probably guess what the next one's going to be. Up, down? Down, down. All right, let's take a guess before we plot it. What do you think x to the fifth is going to do? Same thing as x to the third, which happens to be the same thing as x to the first. And guess what? You're right. What do you think negative x to the fifth is going to do? So by process of elimination here, what do you think x to the 17th would do? Down, up? So you think x to the 17th down, up? X to the 17th down, up. So here's what's happening. I don't know if you've noticed this yet. What's happening, look at the relationship between exponents and their directions. Exponents, or sorry, the leading term and their directions. When it's just x, what's the exponent? 1. X to the third, same thing. X to the fifth, same thing. What does a 1, 3, and 5 have in common? They're odd, right? What do 2, 4? What do 2, 4, and even? So here's what happens. There's only going to be certain patterns here. F of x, if it is x to the odd, if it's positive x to the odd, your tails are always down, up, because as x approaches positive infinity, f of x also approaches positive infinity. As x approaches negative infinity, f of x also approaches negative infinity. And the idea here is tail wings. Down, up, 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 down, down, down. There's only 4 possibles. So if I say x to the 6th, what do you guys do for your tails? Up, up. If I say negative x to the 7th, what do you do? Negative x to the 7th. X to the 3rd. Down, up. Negative x to the 8th. Down, up. So that's the idea. We know how tails will always dance if you know what the leading term coefficient is. You know your leading term coefficient, and you know if it's even or odd. It's where everything comes into play. Okay. Now, same thing goes for if this is, if it's negative x and odd, your tails are always down, up, down. Then we would say as x approaches positive infinity, f of x approaches negative infinity. Did I tell you, well, what does my infinity symbol kind of resemble? How about, nice, that's a good reference, I like that. How about a Pringle? Okay. Did you know that a Pringle is a conic section? A Pringle, this is an OBS thing, a Pringle is a hyperbolic paraboloid. A Pringle is a hyperbolic paraboloid. Pringles were invented by a mathematician who did not want his chips crushed. I know Pringles can still get crushed, but in nature, one of the strongest occurring shapes is an arch. I thought it was an arc. Anyway. Doritos, yes. So that's where the hyperbolic paraboloid comes into play. One weird thing, what I want you guys to think of here with this f of x and the x as what's approaching what, it's easy, or sorry, most textbooks don't just draw tails. I do, because it's easier to remember. Because if you know what's happening on the outer edge, as things are getting to the right, as things get larger, f of x is getting small. Okay? Things like that. That's where that comes from. Textbooks will just write it as x approaches infinity, f of x approaches something. But for some stupid reason, they flip it. They say as f of x approaches negative infinity, x approaches infinity. That's dumb. That's putting the cart before the horse. Because x and f of x are technically your x and y values. Why would you talk about y before you talk about x? Well, these are all functions. Okay? So I've always had a problem with them writing it that way, but that's just me saying my stuff. So that's your odds, your evens, f of x is positive x to the even. Your tails are always up, up. Oops. Okay. So that means that as x approaches positive infinity, as x gets larger, f of x is also getting larger. As x gets smaller, f of x still gets larger. Yes. Might. Yeah. And then as f of x, negative coefficient, even exponent, tails are down, down. Really good at that Garfield reference. I never thought of that. I totally forgot about that. What's that? Really? You're not like scarred or anything about it, are you? What? Patty? What? Wait. So, uh-huh. So she just were they gonna like do an autopsy or something in like 7th grade science? Huh. Interesting. Yeah. This one out real quick. Is that right? Well, it's you got to know the tails if it's how it's written. I just want to make sure you guys all saw that. Okay, want to answer your question? I thought you were just gonna thought you had something to come. Okay. Yeah, you don't want to bat your house. That's happened. That happened to us once when I used to live in Cary. One got in there, but my dad had welding gloves. So the big, thick, heavy leather welding gloves where the bat's not going to bite through it. We had to go pick them up and grab it and put them outside. Yes, ma'am. We never talk about things without math. That's pretty crazy. That's pretty crazy. Yeah. That's pretty funny though. That's pretty good. Pretty good. Good. All right. So the idea here is that we can start to look at end behavior in terms of any of our functions. So if I go back to what I was talking about a second ago, if I go back to this one as I was starting the class with, what are the tails doing on this? They're up. This is x to the fourth positive value. I know that no matter what, my tails do that. The rest of the polynomial stuff as we get going into this, guys, will allow us to figure out what happens within the middle. Now, like I said a little while ago, this one being a fourth degree polynomial means it can have up to and include 4 zeros. It can have, within those 4 zeros, the graph can have 3 up to and including 3 possible changes of direction. And then, excuse me, and then obviously our tails would be up. What we do here in polynomials, and this will start to build up more and more and more, is that we learn how do you find values that you can divide into this that are clean. Now, yesterday you guys learned about direct substitution, and I think we did an example towards the end where we started with x minus 2, x plus 7. If I FOILed that out, I would get x squared plus 5x minus 14. Are you guys okay with that? Okay. Now, I'm just working this in reverse real quick. What are the zeros of that? 2 and negative 7. Everybody okay with that? The zeros would have been 2 and negative 7. So that means that if I took my coefficients here, 1, 5, and negative 14, and I use the synthetic substitution or synthetic division, if I divide out by one of my zeros, my 0 was 2, negative 7. If I divide out by my 0, here's a calculator before. I don't know if you noticed. If I divide out by a 0, watch what happens. What was your first thing to do here? Drop the 1. Multiply. 2 times 1 is? 5 and 2 is? 2 times 7 is? So that means that 2 is a 0. The term that generated it was x minus 2. Remember the relationships that I kept saying between zeros and terms? All right, terms. Parentheses, x minus 2 gives it a 0 of 2. So 2 is a 0 of the term x minus 2. So that means that if 2 was a 0, the term that went into it was x minus 2. Well, when you divide stuff, you're breaking it into other factors. So if I basically factored out an x minus 2, what's left? X plus 7. Yep. So the idea of factoring is going to stem from just being able to find zeros. Okay. Go back to this. Here, we know are tails. Okay. Eventually, over the course of the next 4 or 5 days, we're going to start searching for zeros. So we're going to start. Yeah. Oh, everybody out there. Okay. what we're going to do is we'll start searching for zeros. So I write down coefficients. I get 1, 4, -6, -36, and -27. Everybody okay with that? All right. Now, obviously, you don't know enough of how to do all of this yet, but I've done this once or twice. I don't know if you knew that. I'm going to show you a little. You don't have to follow through completely on all this. You don't have to completely totally comprehend this. But this is the why does math portion of all of this. I know because I've done this problem already today that 3 should work. So drop 1, multiply, add, multiply, add, multiply, add, multiply, add. I know that 3 was a 0. That meant what was the term? X minus 3. I know that I can factor out an x minus 3. Now, if you factor out something, if I took out an x minus 3 out of an x to the 4th, how many degrees are left? 3 of them, 1 less. I took out one of the terms, so I took out one of the values of x. So technically this is now x cubed, 7x squared, 15x, and a 9. Every time I factor something out, I can do that. Okay? Just wait. You don't have to totally understand this yet. I'm just trying to show you guys how fast and easy this is going to become. But try 3 one more time. Sometimes if you have multiple answers. I did it earlier. I'll show you how to do it. It's super easy. All right, ready for it? What are your factors of 27? 1, 3, 9, 27, right? What are your factors of 1? 1. So you're searching 1, -1, 3, -3, 9, -9. There's only 6 possible zeros. How fast is this? You don't have to worry about it now. Okay? 3 doesn't work. It's okay, just watch. All I want you guys to do right now is watch. -3 worked. If -3 works as a 0, what's its term? 3. X plus 3. So right now, in the grand scheme of things, we know that I can take out from that x to the 4th, all that junk. I've taken out an x minus 3 and an x plus 3. I factored those out. When you factor something out, it drops another degree. That means that this is x squared, 4x, and 3. Well, what are the signs here? They're all positive, right? Remember, we're just doing coefficients, so they're just positives. Okay. What times what's 3 add together to get 4? Those are your last 2 terms. So that means, again, you don't have to fully get this right now, guys. That means that this whole function can be factored. Don't worry. Okay, guys, all I'm trying to show you is why this is important as we go forward. You can take something that looked god-awful and through some really easy math, find how to factor it. That means that there are zeros at 3, -3, -3, and -1. Now, yes, sir. Just out of thin air. I knew the answer. Don't worry. I said that Again, guys, you don't have to understand what the hell I just did. You really don't, okay? In a week, you will. And you'll be like, oh, well, that makes sense. All I'm trying to show you is why we start on the outside. Why do you learn substitution to get to this? Now, when you guys had quadratics before, that x squared plus 6x plus 9. If you had the quadratic x squared, plus 6x plus 9, and you had to factor that, you'd say what times what's 9, you had to get them to get 6. 3 and 3, right? So it's x plus 3, x plus 3. But when you graphed that, how many times did it touch the x-axis? Just at once. What happened was it changed direction at -3. It did this. Remember that? Because tails are up, up. Well, your Algebra 1 teacher and your Algebra 2 teacher up to this point never explained to you what this meant. When it changes direction on an axis, it's called to have multiplicity. What that means, it's there more than once. It has multiplicity of 2. It touches it, it has that 0 twice. It's just a double 0. That means it changes direction. So here you have zeros at 3, -3 with multiplicity. Oops. Put this in your graph, in your calculator. I guarantee it looks like this. Put that in your y equals. Put that in your equation. I guarantee it probably looks a lot like that. Yeah, except clear it all out. Yep, x to the 4th was 4x cubed minus 6x squared minus 36 minus 27. The idea here is throughout our time with working with polynomials is that we understand tails first, and then you work your way inward. And you work your way inward by factoring. And all this factoring comes back because of synthetic division. You're searching for zeros. Okay. It's pretty close, isn't it? Obviously, my y-intercept is a little off, but there's a lot of reasons why that happens. We'll get to it. All I wanted to show you guys is as you start thinking about what tails are doing, remember the tails will turn into figuring out the middles. Textbooks tend to have you make tables and substitute in values to find all that. I find that to be a waste of your time. Because in all honesty, why wait to get to the middle by doing a bunch of time wasters, if you will. Okay. So tonight, or for the weekend here, all I have you guys doing are some more synthetic substitutions. That's still all they're calling it. And then I have you just graph the tails, which means all you have to do is do your arrows. Do your arrow days. You don't have to draw the pictures. You don't have to put it in your calculator to see what it looks like. I want you to be able to look at a function. And say, if I look at this function, it loads up. If I look at this function, I know what my tails are doing. 7x cubed. What are your tails doing? Down up. That's what I need. My tails are down up by looking at that. I don't care what's happening in the middle because I have learned all that. Okay. As we go along, we start doing more and more and more. Okay. Do those. Same PDF, 6.2. What's that? Yeah. I don't know. We haven't learned enough to do the middles, but we should be able to knock through all that. Okay. Well, on Tuesday, we'll do the adding, subtracting, which is just combo like terms. Wednesday, we'll talk about multiplying, dividing, do long division. My guess is starting next Thursday is when we'll start factoring in those zeros. Because I know next Friday we've got the half day. I know it's good times. So it'll probably be next Thursday into Friday is when we would start searching for zeros and factoring everything out. All right. It starts complex-ish, but it's all that synthetic over and over and over.